Hello all, welcome to a new video on logic design. In this lecture, I am going to talk about a special code called gray code. This is an important topic and you can expect questions related to this topic in a GATE exam or any other competitive exam. In this video, I am going to explain how to convert a binary code into a gray code. If you are new to my channel, check out the videos on the selected topics from the course of Logic Design and the solutions of the previous year question papers of Logic Design. The links of all those videos have been given in the description box. So without further delay, let's get started. Let us see how to convert a binary to a gray code. For that, I have taken a number here 0 and I have written the binary of this number, that is 0000. Now I have to convert this binary to gray code. For that we have to apply the truth table of the XOR gate. So what is the truth table of the XOR gate? If two inputs, that is A and B, if two inputs are similar, the output is 0. If we are given two similar inputs to this XOR gate, the XOR gate gives the output as 0. If you give two dissimilar inputs to this XOR gate, that is 0 1 or 1 0, you will get the output as 1. So this is the truth table of XOR gate. Now we have to apply this function of XOR gate in this binary. So here the binary code is 00000. 4 bits are there. The first bit is 0. You have to write the first bit as it is. In order to convert the binary to gray, the first step is we have to write the first bit as it is. If the first bit is 1, we will write 1 here. Here the first bit is 0, so we write 0. This is the first step. Now, second step is here. What is the next bit? The second bit is also 0. You have to XOR the first bit with the second bit, that is 0 0. What is the output of 0 0? It is 0. So write that output here. This is the next bit of the gray code. Now XOR the second bit with the third bit. XOR second bit with the third bit, so that you will get 0 XOR 0 is 0. Now the third bit, XOR the third bit with the fourth bit, so that you will get the output as 0. So this is the gray code of the number 0. So the binary of the number 0 have been converted to its gray code. Now let us convert the binary of the number 1 to its gray code. In order to write the binary of a number, we can use this 8421 trick which have been explained in my previous lectures. So here, in order to convert the binary to gray code, the first step is you have to write the first bit as it is. Which is the first bit here? 0. 0 have been written as it is. Now XOR the first bit with the second bit, that is 0 XOR 0. 0 XOR 0 is what? 0 itself. So that is the second bit of the gray code. Next, second bit of this binary is XORed with the third bit. So 0 XOR 0 is again 0. Third bit with fourth bit, 0 XOR 1. 0 XOR 1 is 1. So this is the gray code of the binary 0001. So you can see here the gray code and the binary both are same for 0 and 1. Now let us check for 2. The binary of 2 is 0010. What is the gray code? First bit is written as it is. XOR 0 with 0, you will get 0. Then XOR 0 with 1, you will get 1. XOR 1 with 0, you'll get 1. So the gray code of 0010 is 0011. It is different. The gray code and the binary is different for 2. Now you have to check for 3. 0011. The first bit is written as it is, that is 0 is written as it is. Now XOR the first bit with the second bit. So 0 XOR 0 is 0, 0 XOR 1 is 1, 1 XOR 1 is 0. Therefore, the gray code of 0011 is 0010. Now let us check for 4. The first bit is written as it is. 0 XOR 1 is 1, 1 XOR 0 is 1, 0 XOR 0 is 0. Now for 5, the first bit is written as it is. 0 XOR 1 is 1, 1 XOR 0 is 1, 0 XOR 1 is 1. For 6, first bit is written as it is, that is 0, 0 XOR 1 is 1, 1 XOR 1 is 0, 1 XOR 0 is 1. Similarly for 7, first bit is written as it is, first bit is 0 here, 0 XOR 1 is 1, 1 XOR 1 is 0, 1 XOR 1 is 0. Now for 8, first bit is written as it is. What is the first bit here? It is 1. So the first bit is written as it is. Now 1 XOR 0 is 1, 0 XOR 0 is 0, 0 XOR 0 is 0. Now let us check for 9. The first bit is 1, so it is written as it is. 1 XOR 0 is 1, 0 XOR 0 is 0, 0 XOR 1 is 1. For 10, first bit is written as it is. Now 1 XOR 0 is 1, 0 XOR 1 is 1, 1 XOR 0 is 1. Now for 11, first bit is written as it is. 1 XOR 0 is 1, 0 XOR 1 is 1, 1 XOR 1 is 0. Now for 12, first bit is written as it is. 1 XOR 1 is 0, 1 XOR 0 is 1, 0 XOR 0 is 0. For 13, first bit is written as it is. 1 XOR 1 is 0, 1 XOR 0 is 1, 0 XOR 1 is 1. Now for 14, first bit is written as it is. 1 XOR 1 is 0, 1 XOR 1 is again 0, 1 XOR 0 is 1. For 15, all ones, 1 0 0 0. So this is the gray code for the numbers from 0 to 15. The binary of these numbers have been converted to its gray code. Let us do an example. Convert the given binary number to a gray code. So this is the given binary number 11001110. 8 bits are there in this number. You have to convert this binary to gray code. So the first step is write the first bit as it is, that is 1. Then XOR 1 with 1. XOR 1 with 1, you will get 0. XOR 1 with 0, you will get 1. 0 with 0, 0. XOR 0 with 1, 1. 1 XOR 1, 0. 1 XOR 1, 0. 0 XOR 1, 1. So this is the gray code of the given binary number. When you observe this gray code, the first two gray codes, of 0 and 1, we can see that the first 3 bits are the same, 0, 0, 0. Only the last bit differs. That means 1 bit differs in both these gray codes of 0 and 1. Similarly, when you compare the gray codes of 1 and 2, we can see that the first 2 bits and the last bit is the same in both these codes. It differs in the third bit. Both these codes differs in the third bit. That is, this bit it is having 0 in the third place, and this code is having 1 in the third place. This code is having 0 in the third place, and this code is having 1 in the third place. The rest all bits are the same for these two codes. Similarly, when you compare 2 with 3, you will get the last bit changes from 1 to 0. Rest of the bits are the same. Similarly, when you compare 0, 0, 1, 0 with 0, 1, 1, 1, 0, that is when you compare 3 and 4, the gray code of 3 and 4, you can see that the second bit changes from 0 to 1. The other bits are the same. 0, 0, 0, 1, 0, here 0, 1, 1, 0. When you compare 5 and 6, first bit is same, 0, 0, second bit 1, 1, third bit differs. 1 changes to 0 and the last bit again it is the same. Similarly, for all the other codes, gray codes, it differs in 1 bit. All the codes differs in 1 bit from its adjacent code. Therefore, it is called as unit distance code. Because of this nature of this gray code, it is called as unit distance code. When you check the last two codes, that is of 14 and 15, the first bit is the same, second is same, third is same, the last bit differs from 1 to 0. Therefore, this gray code is also called as unit distance code. Now, another nature of this gray code is, notice the gray code of 0 and 15. Gray code of 0 and 15. It reflects as well as it changes in 1 bit. This changes in the first bit. Here the first bit is 0, here the first bit is 1. All the other bits are same. Similarly, when you compare this 1 with 14, you can see that the second, third and fourth bits of 1 and 14 are the same. Only the first bit changes from 0 to 1. Next, when you compare 2 with 13, you can see that this is reflecting 0, 1, 1. Here also you have 0, 1, 1. The first bit changes from 0 to 1. Similarly, you can compare the other bits, like here you have 4 when compared with 11 and so on. You can see that the only 1 bit changes, the first bit, and the rest all bits are reflecting. It's the same. Therefore, it is called as reflective code. This gray code is also called as reflective code.